Hey guys, it's Roya, and today I'll be teaching you how to use velocity graphs in order to find change in position. Now, say we have old Mr. Bunbury, and he's 90 years old, he doesn't really know what's going on. He drives at a constant rate of 9 meters per second, which is about 20 miles per hour, and he drives at the same velocity no matter what. Even if it's a red light, even if he's on the highway, he's going 9 meters per second. Now, we want to figure out how many meters Mr. Bunbury has traveled after 10 seconds. And in order to do this, we have to use the formula of change in position equals velocity times change in time. Now, if we multiply velocity, 9, by the change in time, 10, we would get the same answer as if we found the area of this rectangle right here. Because, as we know, the area of a rectangle is the base times the height. And the base is 10 seconds, and the height is 9 meters per second. Therefore, we get change in x equals 900 meters. Now let's take a different example. What if you and your friend were at a red light and you guys are total bros and you want to race to see who can accelerate the fastest? So you press your gas pedal and suddenly you zoom off and you start accelerating at constant acceleration, which we'll go over in the next video. Here you have a velocity of 0, and eventually you reach a velocity of 100 meters per second, and you do that in 10 seconds. Now you want to figure out how far from the stoplight you are at 10 seconds. We can do the same thing. We can find the area under the graph. And in this case, since it's constant acceleration and not constant velocity, their area is going to be a triangle. As we know, the area of a triangle is 1/2 base times height. And that gives us 1/2 times the base, which is 10, times the height, which is 100, and that gives us 500 meters. So you guys have traveled 500 meters in 10 seconds. That's a lot better than Mr. Bunbury. Now, why does this make sense? Why do we use only half and not the whole rectangle? Well, this is because you start at a velocity of 0 and you end at a velocity of 100, and you want to find the average velocity in order to calculate this rectangle right here. You need to use the average velocity. Now, the average of 100 and 0, 100 plus 0 divided by 2, is 50. And you can find the area under this rectangle as 50 times 10, which is the same thing as 500, and we end up with the same answer.